Alright, we're going to do Chapter 7. We're going to talk about Chapter 7. This is our first video, so we're going to talk about rational expressions. We're going to talk about rational expressions here. If we're talking about rational expressions, we're going to talk about defining rational expressions. We're going to evaluate a rational expression. We're going to talk about restricted value for rational expressions. And this, by the way, is Section 7.A, or 7.1, Video A. It's our first video for the chapter. So let's see what we can do with the introduction to rational expressions. We're going to, like I said, define rational expressions, evaluate, and kind of talk about restricted values. So what is a what is a rational expression? A rational expression is, well, if we talk about what a number is, a rational number is just the ratio of two integers. So here's an example: if we're worth 1 over 4, or 1 over 2, or 2 over 3, those are all just rational numbers, because you got a number on top and a number on bottom. A rational expression is a ratio of two polynomials. So up here it was a ratio of two integers. Now a rational expression is a ratio of two polynomials. So here's a couple of examples. 3x minus 6 over x squared minus 4. 3x minus 6 is a polynomial. X squared minus 4 is a polynomial. 3 is a polynomial. 4 is a polynomial. 6r to the 5th is a polynomial. All these are just polynomials. And as long as we have the ratio, we've got a rational expression. We'll talk about rational equations later on when we introduce equal signs, but for right now we've got rational expressions. So we're going to talk about evaluating a rational expression. If we evaluate, it's just like evaluating any other expression. We simply calculate the value for it, and oh, by the way, over here we're going to have some things that are more challenging. So essentially what we're doing in this evaluation is we've got an expression here, rational expression. Here's a polynomial, and all we're doing is evaluating this for example, x equals 0. So what we do is we say, well, I'll start with my 12 over x minus 3, and if I'm going to evaluate that, I say that's equal to 12 over, well, when x is 0, then we say it's 0 minus 3, and we evaluate that's equal to 12 over negative 3, and that's equal to negative 4, and there's our evaluation. So if we evaluate for x equals 1, we do the same thing, 12 over x minus 3. Start with our rational expression. We substitute then 1 into our x. We say 12 over 1 minus 3 is 12 over negative 2, and that's equal to negative 6. So all we're doing is just evaluating this. X equals negative 3. Well, you know, that might jump out at us that we might have some issues here, but we don't really, because we can, if we just simply evaluate, we substitute in negative 3 in for x. 12 over negative 3 minus 3 is 12 over negative 6, and that's equal to negative 2, and there's our problem, and there's our situation, there's our evaluation. So over here though, what do we have for x equals 3? If we have x equals 3, we evaluate that. We say it's 12 over x minus 3. Instead of x minus 3, it's 3 minus 3, because we're substituting in x, and x equals 3 right here, and we're evaluating. That's equal to 12 over what's 3 minus 3 is 0, and 12 over 0 is, as we know, undefined. Any division by 0 is undefined. So right here we've got something that's undefined. So over here, everything over here on the left, we can evaluate. We can evaluate this. We just get a value for this expression, that 12 over x minus 3. We've got a value for it. When we substitute x equals 0, we've got a value. When we substitute x equals 1, we've got a value. When we substitute x equals negative 3, we've got a value. When we substitute x equals 3, we have a problem. We have an undefined situation. So does d have a value? Not really. It's undefined. So if we need to, we can plug in 12 divided by 0 and say, well, the calculator tells me that it's not a valid number. So we move on. We say, kind of leads to the our third topic of restricted values. For restricted values of a rational expression are values that make the denominator equal to 0. So there's a definition. If you're looking to set up something for your study guide, restricted values are values that make the denominator 0 of a rational expression. So sometimes it's easy to see what they are. Sometimes it's a little more difficult to calculate what they are. So let's find out what the restricted values are for A. Here's our rational expression here in the blue box. Restricted values for this in the blue box are any values for our variable. In the previous example it was x, here it's y. Any values for the variable that make the denominator equal to 0. So what we do is we say, well, let's set this equal to 0, and if that's equal to 0, 2y plus 7, that's our denominator. If that's equal to 0, then we're dividing by 0, and that's where we have our restricted value. So if 2y plus 7, this denominator, equals 0, we've got a problem, and now we find out the values for y, for whatever that restricted value is, and we just simply solve this mini equation. We subtract 7. Add a negative 7, and we subtract 7 on the right as well, so we're just subtracting 7 on each side. I got 2y equals negative 7, and then we just divide by 2 on the left side, divide by 2 on the right side, and we got y equals negative 7/2. And there's our restricted value for this equation, because if we substitute in negative 7/2, negative 7/2 times 2 is, the 2's cancel out, and we have negative 7. Negative 7 plus 7 is 0, and we've got a restricted value because we're dividing by 0 when y equals negative 7/2. Sometimes they jump out at us. What's the restricted value for b? If I get restricted value for b, then, well, my denominator is equal to 0 when we've got a restricted value, or I guess when my denominator x equals 0, then we have a restricted value. So that's easy to say, that if x equals 0, then we have a restricted value, because then we're dividing by 0. How about question number C? I've got C is 8. What's the restricted value for 8? 8 is a polynomial. 8 is a rational expression. If we define it, or I guess if we redefine it, we can say it's 8 over 1. So what is the restricted value for 8, or 8 over 1? Well, if 1 equals 0, then we have a restricted value, but when does that happen? Never. So we have no restricted values for this expression over here, this rational expression over here. Sometimes, just like in chapter 5, we've got to do a little factoring. Probably in a lot of them, we've got to do factoring. So basically what we're going to do is we're going to find restricted values for these expressions down here. Again, we've got rational expressions down here. Here's my a. If I've got a is a plus 10 over a squared minus 25, this is question A. When do we have a restricted value for this? Well, if a squared minus 25 equals 0, then we have a restricted value, but we can't really solve that. We could probably the best way to do this would be to factor this a squared minus 25. From chapter 5, we remember that a squared minus 25 is a difference of squares. Here's a square, and there's a difference between them, so that factors into a minus 5 times a plus 5, and we still set it equal to 0, so that when that happens, that's still our restricted value. So then we say that either a minus 5 equals 0, or a plus 5 equals 0, and if either of those situations happen, we have a restricted value. So if by adding 5 over here we get a equals 5, by subtracting 5 over here and on both sides we get a equals negative 5. So really down here we've got two different situations. A equals negative 5 or a equals positive 5 will get us the result of dividing by 0, and those then are restricted values, because a equals 5 and a equals negative 5 makes us have a division by 0 up here. A equals 5 means if we evaluate this, we get 5 squared is 25, 25 minus 25 is 0, and we're dividing by 0 over here. If we have a equals negative 5, a squared negative 5 squared is negative 5 times negative 5 is positive 25. 25 minus 25 is 0, and we're dividing by 0, so there is again another restricted value. Let's take a look at B. If we look at B, what's our restricted value for that? Well, restricted value happens when x squared, or the denominator, x squared plus 9 equals 0. And let's see, can we factor this? This is a sum of squares. We can't really factor that. So we could say, well, how about x squared if we subtract 9 and subtract 9? We get x squared equals negative 9. When does x squared equal a negative number? Never, because it's either a positive times a positive is positive, or a negative times a negative squared. In other words, a negative squared is still a positive as well. So when does this happen? Never. So for this one, we have no restricted values. For rational expression B, we have no restricted values because x squared plus 9 is never equal to 0. So therefore, there's no restricted values. So there's the definitions of rational expression, basically a polynomial over polynomial. evaluating rational expressions essentially means plugging numbers in, like x or y, into our rational expression and finding a value for it. And the restricted values of a rational expression simply mean if we're dividing by 0, what values for our variable give us division by 0 in our rational expression. So there's our summary for 7.1.